Okay, this is addition reactions. We're going to look at structural drawings, semi-structural formula, and naming of all of the chemicals. So addition reactions happen with alkanes. Alkanes are molecules that are unsaturated, meaning that they have a double bond, a carbon-carbon double bond. And an addition reaction is going to break that bond, and you're going to add another molecule to either carbon. You can tell if something is an addition reaction because the two reactants add together to make one product. So if you only have one product, then it's possibly an addition reaction. So the first reaction we're going to look at is the alkene ethene with bromine, Br2. This is a classic test for unsaturation. Unsaturation meaning that you've got a double bond, because bromine is brown in color. So this is the two initial test tubes here. We've put some brown bromine in both, and then we've poured in whatever chemical that we're testing to see if it's unsaturated or not. This particular one, you can tell that the two chemicals are different densities. The alkene is sitting on top of the bromine at the moment. So a reaction occurs, and now the bromine is no longer Br2, so it becomes clear and colorless. So this must have had a double bond. No reaction has occurred, but the density of the bromine is less than the density of the alkane. This was an alkane that was added here. It was more dense than the bromine, so over time they've swapped positions, but it hasn't reacted. So it's lucky for us that bromine is brown, so you can remember that adding brown bromine is a test for unsaturation. So I'm just going to pause this and draw what's going on for this reaction. Okay, so I'm going to draw out what's going on here to show you what's happening with the electrons. So if I draw the ethene really large, these bonds are because the carbon is sharing 4 of its electrons. Carbon has 2 and 4. It needs to make 4 extra bonds. So 2 of the electrons are being shared with the other carbon, and 2 of the electrons are being shared with the hydrogens, so that you get 4 bonds. Okay, so 1, 2, 3, 4. So there are 1, 2, 2, 4, 6, 8. So the carbon has 8 electrons around it. So if I show this bond and keep it connected, the other bond breaks. So we'll draw our bromine down here. Bromine, it's sharing, it's 2, 8 and 7. It's 1 extra electron. So it's forming, it's got 6 electrons in pairs, lone pairs, and then the 7th electron is being shared with this other bromine to form another bond to make 8. Okay, so rather than these electrons being shared here, this bond is going to break, this bond is going to break, and a new bond will form between this carbon and the bromine. Okay, so this bond breaks, this bond breaks, this bond breaks, and this electron and this electron are now being shared between the carbon and the bromine, and this electron and this electron are now being shared between the carbon and the bromine. So you end up with the carbon bonded to the bromine, which is what's happened over here. The classic mistake when students add something, they might add both of whatever they're adding to one carbon, or they might forget to break one of the bonds. So your product here ends up with 2 bonds still, or you've put, instead of having whatever you're adding, 1 on each carbon, you've accidentally put them both on 1 carbon. Alright, so the previous example that we did ended up with 1,2-dibromoethane. Should go back and do the name for that. 1,2-dibromoethane. Alright, so this is a 1, 2, 3, 4. It's a bute because it's got 4, and it's an ene, and the double bond is on the first carbon, so it's a bute-1-ene. So this bute-1-ene can react with hydrogen chloride molecules. The bond here will break, the bond here will break, and this hydrogen will be added to that carbon, and this chlorine will be added to that. So you can make, the chlorine is on the second carbon, so it's 2-chlorobutane. This molecule here could be flipped over so that the hydrogen is actually going to be on that, or the chlorine is on this, in which case you would make 1-chlorobutane. So I might just draw that. Okay, so if we put our bute-1-ene here, and our hydrogen chloride molecule, you can see that the electrons here can break instead of being shared between the hydrogen and the chlorine, and instead of this electron here and this electron here being shared between the carbons, they can then be shared between this carbon and this hydrogen, and this carbon and this chlorine. So then there will be a bond here and a bond here. And I have drawn this ridiculously long, these bonds. So having the chlorine on the second carbon, 1, 2, 3, 4, so it's still a bute. It's not a butene anymore. Remember, it's got a single bond, so it's butane. And if the chlorine's on the second one, then it's 2-chlorobutane. 1, 2. Alright, so if this molecule was flipped over, so the chlorine was here and the hydrogen was there, and you can see that when that breaks, you can get the chlorine on the first carbon and the hydrogen on the second carbon. So you would get 1-chlorobutane. Okay, if I drew it out like this, it might look a little bit more normal. So of the first carbon. This makes this a little tricky because I said before that addition reactions make 1 product, but you can end up with 2 products if each time an addition reaction happens, you make 1 product, but clearly with a whole mixture of these, you're going to end up with 2 products. One of them may be more often than the other, but 2 products depending on how this approaches the alkene. Okay. Our poster has got water breaking and specific conditions. Because water is not very reactive, it won't break these double bonds. It needs a bit of help. So if you give it some energy, some heat to break the bonds, and a catalyst to help start breaking the bonds, then it will make an alcohol. Okay, so there are 2 ways to make an alcohol. Okay, so the example was with the nice easy ethene. and we're going to make ethanol. So if I draw the water molecule so that one of its bonds is able to be broken, then I can break that bond with 2 electrons, break this bond with 2 electrons, and these 2 electrons can form a bond holding that hydrogen onto here, and these 2 electrons can form a bond holding the hydrogen onto here, which is a very, very strange looking drawing of an ethanol molecule. So if we just, these can flip around and move, obviously, rotate, so that I can draw it like this. Technically it's like this. We did a skeletal diagram. Every carbon is one end of a line. Okay, and then this carbon links to that oxygen and hydrogen. So this would be a skeletal drawing of ethanol. And we've done that from our ethene, and that's actually a drawing of, oops, sorry, with two lines. That's a drawing of ethene, skeletal drawing. So if we link what we've done to our pathways, so we're looking at addition reactions here, double bonds breaking. If we add a water molecule, then the OH bond can go onto one of the carbons to make the alcohol, and the hydrogen can go on to the other carbon here. So there are 2 ways to make alcohols, so you need to be careful if you've made it alcohol. Have we come from a double bond? Is the previous box a double bond, or is the previous box a chloroalkane? So you need to look at the chemicals that you're reacting. This one here is a little bit tricky, because if you've got water with a catalyst, a vague catalyst, it could have been a chloroalkane. If you've got water with phosphoric acid and heat, then it could have been an alkene. So for you to know which one of these has happened with water, you would need to know a bit more about your original reactant. Addition reactions, you can, if you add a hydrogen to one carbon and a chlorine to the other, you could make a chloroalkane, or if you broke the bonds and added hydrogens to either, you would make an alkane. Technically also, you could add an ammonia, NH2, to one carbon, and hydrogen, the other hydrogen, to the other carbon. Remember, nitrogen has 3 bonds, so if one of them is bonded to that carbon, then the other hydrogen would be bonded to the other carbon. So you could do an addition reaction with ammonia.